2987, yes. It might be a very Jessica, oh, not yet. You're not there yet, are you, Jessica? Jasmina, Cassidy, you there?
Yes, hi.
I'll be with you in a second, guys. All right, Gabe is here. I've got two of you, or three of you here anyway. Jessica's having a hard time getting in here. Hi, Gabe. Hi, Gabe.
Hello.
Gabe, you're very, very low. Your volume.
How it is?
I can barely hear you, Gabe.
Hello, hello, hello.
Maybe that's my fault. Hold on a second. Try again, Gabe.
Hello.
No. 1 second. Yeah, that's the problem. Try again.
Hello, hello.
Yeah, the problem was my speakers were a little bit low. I put on a video yesterday that it was very the volume was real high, real low, so I had to turn the speakers up high. Then I had to turn them back. How we doing, guys? Pretty good.
Good.
I get a
How are
couch
you?
and love seat, so. Ooh, there went $3,000
$3,000?
for a couch and love seat. Yeah.
Oh, geez.
Jeez.
This, you haven't searched for furniture? You haven't bought furniture yet?
Well, the couch that I own, I bought off Facebook Marketplace for like $250, split between my roommate and I. So,
Okay, good enough.
and Facebook Marketplace is a great place for furniture and all that.
Should have known. Should have looked on it. What can I say? I'm sorry, I'm old. I go the old-fashioned way. I go to furniture stores. Okay, guys. I don't know if anybody else is going to join us, but really and truly, I think this is where things start to get a little bit harder. Okay, because how did you guys have problems doing reactions in intro? Being able to predict what was going to happen and things?
Not really.
Not really? Okay,
Yeah,
good.
not really.
Fine as kind. Well, we're going to get through. It's going to take the better part of this period and the next one to get through this. I'm hoping to get through reactions and moles by the end of the next period. Then we're going to spend the whole day on September 10th doing empirical formulas. The test will be on the 15th. Okay, just to give you an idea of what's coming up. Okay, guys, what we're going to do is we're going to learn how to balance chemical equations. We're going to deal with double replacement reactions. In double replacement, we're going to do ionic and net ionic equations, and you have to understand you can do ionic and net ionic equations and apply them to single replacement reactions. We're going to deal with combustion, and the last couple of things we're going to deal with synthesis and decomposition, but in all told, there's not really a whole lot that I'm going to hold you responsible for there. The only thing really I'm going to hold you responsible for is being able to identify that it is a synthesis or it is a decomposition reaction. So basically, the things on the left side of the arrow are the reactants. Things on the right side of the arrow are the products. The products are the stuff that forms. The reactants are the stuff that undergoes the chemical changes. Now remember, Lavoisier said matter cannot be destroyed or created. What that means to you is that the number of atoms on the left side of the equation has to equal the number of atoms on the right side. Now, I don't care how you go about balancing. I'm going to show you what I do to balance chemical equations. You don't have to do it that way, but I would suggest that you do get a system and continue to use that system. If that system works for you, great. If it doesn't work for you, you might want to think about doing it my way. Okay, the first thing in any chemical equation, all the individual chemicals must be balanced. Jasmina, how do you balance a chemical?
With the coefficients?
Not the coefficients. You've used the coefficients to balance the equation. What do you do to balance the chemicals? What do you change? All right, let me ask you this question, Jasmina. If you have AlCl, aluminum chloride, Al has a +3 charge, chloride has a -1 charge. How do you balance that chemical?
You make sure that the atoms are equal in number.
How do you do that?
Like cross multiply thing.
Well, what do you change? What
The
numbers have to be added
subscripts?
where?
The subscripts?
Subscripts, that's the magic word I'm trying to get you to say. All right,
Sorry.
the first thing you have to do is you have to balance each chemical in the equation. All right, once you balance the chemicals, do not touch the subscripts again. Balance the chemicals as they appear in the equation. If you change the subscripts, you change the molecule. So NO2 is not the same thing as NO3. Now, as I said a little bit earlier, you balance the equations by putting coefficients in front of the molecules. If no number is there, assume it's 1. And you have to understand that the number of atoms is the product. In other words, the multiplication of the coefficient times the subscript. If the molecule has a parentheses, then the subscript outside the parentheses multiplies all of the atoms within the parentheses, and then that gets multiplied by the coefficient. Okay, my rules. Balance all the cations except hydrogen. Then balance the anions except oxygen. If you have a polyatomic ion and it doesn't change going from left to right, treat it as a unit. Then you balance the H's, balance the O's, and recheck everything. Okay, I have sulfuric acid plus sodium hydroxide making water and sodium sulfate. All the chemicals are balanced. Sodium has a +1 charge. There are 2 of them. That balances with the SO4. H2O is balanced. Generally speaking, when I give you chemicals, assume that they are balanced. If they're reactants, assume the reactants are balanced. Do not assume that the products are. Okay, now, first step, I'm going to balance the cations, all the cations except hydrogen. There's 1 sodium on the left, 2 on the right. I need to put a 2 on the left. I need to get 2 sodiums. So I ask myself, what times 1, because the subscript of sodium is 1, what times 1 will give me 2? I put a 2 in front of the sodium hydroxide. Next thing, okay, I balance the anions except O. The OH changes. The polyatomic OH changes, so I can't treat that as a unit. But SO4 doesn't. I got 1 on the left, 1 on the right. It's balanced. So I've balanced all the cations except H and all the anions except O. Now I balance the H's. I have 2 H's from my sulfuric acid, and I have 2 H's from my sodium hydroxide. I have a total of 4 H's. I've only got 2 on my right side. So I have to put a 2 times 2. I have to put a 2 in front of the H2O, and that will give me my balanced hydrogens. Now I look at my O's. I have 2 O's on the left, 2 O's on the right. I'm balanced. I go through and check everything. Everything is copacetic. I have a balanced chemical equation. We good, guys?
Yes.
Jessica, you've joined us. Hi.
Hi, I've been here.
Yeah, but you had a hard time. You're having a hard time getting your audio on.
Oh, yeah.
Don't know why, but good, Jessica. I got you.
Okay.
All right, now look at this equation. I've done the first step. All of the chemicals are balanced. The subscripts are good. Do not play with the subscripts ever again once you have them balanced. So Jessica, how many aluminums do I have on the left?
2,
Left.
6.
I told you. 6? Hello, Jessica, how many
Yes.
aluminums do I have on the left?
Oh, I was looking on the bottom. Okay. Just 1,
How many do I have on the right?
2,
So what has to be multiplied by 1 to get 2?
2.
So I put a 2 in front of the AlCl3, okay? Now, on the other hand, my sodium has 1 times 2. I've got 2 sodiums, 1 over here. How do I fix that, Jessica?
Put a 2 in front of it.
Put a 2 in front of the NaCl, all right? So my cations are now balanced. I got to look at my anions. So how many chlorines? You're done, Jessica Cassidy. How many chlorines do I have on the left?
6.
How many do I have on the right?
2.
Fix it.
Would you double both of them?
If I do that, then I've got 4 in front of here. 4 times 3 is 12. And I got 4 times 1, that's only 4. Are they equal?
No.
Remember, I've got 6 on this side. I've only got 2 times 1 here. Now, what do I have to multiply 1 by to get 6?
6.
Okay, so I'm going to put a 6 in front of my NaCl. So my chlorines are now balanced. All right, now let's look at my oxygens. How many oxygens do I have on the left, Cassidy?
1.
On the right?
3.
So what do I have to do to this guy?
Put a 3 in front of it.
Put a 3 in front of it. Okay, so now my anions are balanced. I have no extra O's or H's. I'm going to look. Lo and behold, 2 times 1, I have 2 aluminums. 1 times 2, 2 aluminums. 3 times 2, 6 sodiums. 6 times 1, 6 sodiums. 2 times 3, 6 chlorines. 6 times 1, 6 chlorines. 3 times 1, 3 oxygens. 1 times 3, 3 oxygens. Are we good with this, guys?
Yes.
And does anybody not have confidence in doing this? I'm hearing crickets. If I hear crickets, I go on. You guys are seriously good about this?
Yes.
Yeah.
All right. Now, and just seeing who's here. I'm getting less and less people every week. Am I that boring?
No.
Nobody is saying anything.
I said no.
Okay. Now, I'm going to explain something that will help to explain something else. All right. Now, if I have the first kind of double replacement reaction we're going to talk about is called a precipitation reaction. A precipitation reaction occurs when you mix 2 chemicals that do dissolve in water and you create one that makes a solid and it falls out. Make sense? Does it make sense, guys?
Yes.
All right. If I have an ion in water, what happens? I have all these little water molecules out here, right? And so what the waters do is they eat in to the crystal of the sodium chloride. The hydrogen ends get attracted to the chlorine, and the hydrogen ends, because this is a polar molecule, the hydrogens are positive, the oxygen is negative. The water works its way in here and separates that chlorine from the crystalline structure. And so the chlorine ions are completely surrounded by the H's in water. By the same token, the sodiums are attracted to the oxygen portion of water. So around sodium, you get the oxygens of water, and they completely surround it. So that when we're in solution, we have totally separated sodium ions and chloride ions. What happens in a double replacement reaction is we create a product. The product does not dissolve in water. Before, we had 2 things that did dissolve in water. Now we have a chemical with a new chemical property. It doesn't dissolve in water. Therefore, we've had a reaction. And if I'm looking at what's really happening, I have all these ions that are in solution. The A finds a D, makes a new compound, and it falls out of solution. Whereas the B stays in solution and the C does. So if I take a clear liquid of sodium chloride and I take a clear liquid of silver nitrate, the silver finds the chloride and makes a crystalline material that doesn't dissolve in water. It falls out. The sodiums and the nitrates still stay in solution. So if I have 2 things that are in solution, if I have one compound that's ionic that is in solution as its ions, and I have another compound that's in solution because of its ions, and what I create is a new compound that's still dissolved, its ions are in solution, and I have another another compound whose its ions are dissolved in water. No reaction has happened because you still have the same things on the left as are on the right. There's no change. It doesn't matter whether the A plus came from AB or AD. It doesn't matter. There's been no change. It doesn't matter that the D minus came from CD or AD. It doesn't matter. It's the same thing is on the left of the reaction. The same thing is on the right. So when we are dealing with precipitation reactions, if you mix two things that are clear, you mix two solutions that are clear, and you create something that doesn't dissolve in water, you formed a precipitate, there is a reaction occurring. You can also get evidence of a reaction occurring if you get a change in color. If you take iron nitrate, clear solution, and you take sodium thiocyanate, clear solution, mix them, you create iron thiocyanate, which has a brilliant blood red color. If a color forms, you have a reaction because it has different properties than it had before. If you evolve a gas, for example, if you mix sodium carbonate with hydrochloric acid, sodium carbonate solution doesn't have any gas in it. HCl doesn't have any gas in it. But when you put the two together, we get really foaming up, lots of bubbles. We have evidence of a chemical reaction. If you exchange electrons, this is called a redox equation. And we're not going to really get into it. Single replacement reactions are redox reactions, but we're not going to really get into it because they're complicated. You will get into them when you get to Chem 2. So how do you know if a precipitate forms? You have something called a solubility chart. And this could be reversed. It depends upon the person making the chart. In the chart that I have, I've got the first vertical column lists all the cations. The bottom horizontal, or actually the top horizontal, makes the anions. So I have the anions on top. I have the cations on the bottom. Basically, you put one finger on the anion, one finger on the cation. So if I have iron iodide, iodine mixed with iron 2, I look here, I get an AQ. AQ means it is soluble. On the other hand, if I have barium carbonate, I have the carbonate, I have barium. Where the two meet, it says S. S means solid. That means it doesn't dissolve in water. Then you have some things that are indeterminate. And at that point, well, first of all, I'm not going to give you one of those in a double replacement reaction. And I've got that. So what is happening? Let's look at this. First of all, does anybody know how you recognize a double replacement reaction? What is special about these that I can look at those two chemicals and know I'm talking about a double replacement reaction?
When there's two compounds on the reactant side?
What's special about the two compounds?
They're both ionic.
They're both ionic. So guys, if you get a reaction that lists two reactants as both being ionic, then you have a double replacement reaction. And what happens in a double replacement reaction is the first cation gets linked with the second anion. The second cation gets linked with the first anion. And we have this rearrangement. Anybody know the Flintstones?
Yes.
Who are the main characters?
I think one of them was named Fred.
Fred. Who's his wife?
Oh gosh, I couldn't tell you. I haven't watched that since I was a child.
Wilma.
Wilma. Fred and Wilma. Now, who's the other couple?
Betty.
And
That is name. Barney.
Barney. So we have Fred and Wilma and Barney and Betty. All right. The Flintstones were made in the 70s, right, guys?
Yeah.
Yes.
All right. There was this real big thing that was going on in the 70s called a key party. Okay. Now, what couples would do when they went to a key party is the husband would throw his keys into this big jar. Then they would blindfold all the wives. And the wives would reach their hand into the jar and pull out a set of keys. And whoever's keys those belonged to, the wife went with that person. It was called a swingers party. So, Fred and Wilma and Barney and Betty are in this key party. Wilma reaches in, grabs Barney's keys. So Wilma goes with Barney. Betty reaches in and grabs Fred's keys. So Betty is now with Fred. And we have two new compounds. Now, if I have two new compounds, remember in a double replacement, first cation goes with the second anion. Second cation goes with the first anion. What I want you to do when you are making the prediction of the products, I just want you to put them together first. All right, put them together. I got lead with chlorine and I got sodium with nitrate. Okay, then I'm going to go up to my solubility chart. I have sodium, which is here. I'm going to go over till I get to nitrate. I have an aqueous. Did a reaction occur?
No.
Not from the sodium and the nitrate. On the other hand, I'm going to go with my lead. And I'm going to go over to my chlorine. Looky what happened here, guys. Did I get a reaction to occur?
Yes.
All right, so if you get two aqueuses, like for example, if I mixed sodium chlorate with lead nitrate, then my chlorate with the lead is aqueous, my sodium with my nitrate is aqueous. I did not get a reaction. All you have to do at that point is say no reaction, and you're done with that. So the first thing you do is you find out whether a solid forms. Put the products together, okay, lead and chlorine, mix a solid, so a reaction did occur. Now, what you have to do is you have to balance the molecules. Lead has a +2 charge, chlorine has a -1 charge. How do you balance lead and chlorine then? Come on, guys, simple questions. Lead has a +2 charge, chlorine has a -1 charge. What are the subscripts?
PbCl2.
There we go. And sodium has a +1, nitrate has a -1. Is it balanced?
Yes.
All right, so I've got my balance, all my chemicals are balanced. I go on to the first step. I look at my sodium. One sodium, one sodium. Am I balanced?
Yes.
One lead, one lead. Am I balanced?
Yes.
Okay, I got one Cl, two Cls. Am I balanced?
No.
What do I fix it?
Put a 2 in front of the NaCl on the reactant side.
Okay. Now I have 2 NO3s. I have 1 NO3. Fix it.
Put a 2 in front of the NaNO3.
I do that and I check everything out. I am balanced. Does this make sense or am I going into too much detail?
Makes
I think it
sense.
makes sense.
Makes sense.
If I'm going into too much detail, guys, let me know. All right. Gabe,
Yes.
do I have 2 ionic compounds as my reactants?
No.
No?
Oh, no,
Is
you do,
barium
you
a
do,
metal,
you do.
Gabe?
Yes.
Is potassium a metal?
Yes.
If you have metals in the compound, do you have
Okay, yeah,
ionic
they are.
compounds?
Yes.
So I have 2 ionic compounds. I recognize this. That is going to be a double replacement. Now, Gabe,
yes.
put the first cation with the second anion. Tell me what the product is.
All right. Barium sulfate.
Barium sulfate. Okay. Now put the second cation with the first anion.
Would it be potassium, right? Where is it? It's, yeah, potassium chloride.
Uh-huh. I have my 2 products of barium sulfate and potassium chloride. Now remember, I have not balanced them yet. Okay, so I'm going to go up to my solubility chart. Gabe,
Yes.
is barium sulfate, do I have a solid there?
Yes.
Did a reaction occur?
Yes.
So now I know that a reaction occurred. If a reaction occurred, sorry, gotta figure this out where I'm at. If a reaction occurred, then I go and I have to balance the products. Jasmina, have I picked on you yet today?
Yeah, but I'll go again.
Okay, barium has what charge? Guys, you should have your periodic tables around.
Let me get it real quick. Sorry.
Cassidy, what is barium's charge?
Barium is +2.
Sulfate?
Sulfate, 3 minus.
No.
Sorry, I don't have like my polyatomic.
Okay, do you know what the formula for sulfuric acid is?
SO4 2 minus.
SO4 is 2 minus. Okay, and by the way, it's sulfuric acid is H2SO4. So if you know another compound, you can kind of figure out what the charge is
Yeah.
sometimes. Okay. So bariums are +2, sulfates are -2. Is it balanced?
Yes.
K is a
Potassium is a +1.
chloride.
Chloride is -1.
So it's balanced. Okay. Now I got 1 barium left, 1 right. I'm good. I got 2 potassiums left, 1 right. Fix it.
Put a 2 in front of the KCl.
Okay, I now have 2 Cls on the right, 2 on the left. I'm good. 1 sulfate on the left, 1 on the right. I'm balanced. All right. Are we good with this or can I go on?
I'm
You
all
can
right.
go on.
Everybody? Does
Yeah.
anybody want me to do another example? Please don't be embarrassed, guys. I have other examples out there because other people have wanted other examples. Okay, if you want to, you can look through them. This one is probably the hardest to balance. Now, when you're doing these reactions, you have to put what state the chemicals are in. G for gas, S for solid, L for liquid, AQ is aqueous. That means that the substance is designed as an ion. All reactants and all products must be designated. Okay, I'm going to want, right now, I want you to look at these. I just want you to predict the products. Okay? I want to have confidence that you know this. Ian, you out there, Ian?
Yes.
First one, BaCl and sodium carbonate. What other products did I make?
You would make A, B, wait, what is it? A, B, C, D, A, D. BaCO3 plus, so barium, what is that, carbonate?
Yep.
And then Na plus Cl2 would be sodium chloride.
Sodium chloride. Okay. Jessica, silver nitrate and iron chloride. What are the products you make? Jessica?
Oops. Oh my gosh.
Silver nitrate and iron chloride. What are the products you make?
Silver chloride,
And
iron nitrate.
okay, good. You almost you exhibited something that I want to make sure that you know. Never put the anion first. The cation always goes first, okay?
Right.
Cassidy, ammonium carbonate and nickel acetate.
So it would be the ammonium acetate
And
and nickel carbonate.
absolutely. All right. Again, just as a little bit of a review. You recognize the double replacement because you have two compounds that are ionic. They're ionic because the first element is a metal or it's NH4. Second thing you know to predict the products because the first cation goes with the second anion and the second cation goes with the first. Guys, if you're looking at an ionic compound, the first element, if it's not NH4, the first element will be the metal. Everything else is going to be the anion. So we've predicted the products. The next thing we do is we look at a solubility chart to see if one of them is a solid. If one of them is a solid, we know the reaction has occurred. If the reaction occurs, balance the chemicals on the product side, then balance the reaction. Are we good with this? Are we good with this?
Yes.
All right. Next thing we're going to get into are ionic and net ionic equations. All right. I have a balanced chemical reaction, almost. Okay. I have a balanced chemical reaction. Now, I have to think about how this reaction really exists. If I have a solution of aluminum chloride, how does that exist? I know it exists as ions because it says AQ there. So I have to break this up into its corresponding ions. When I designate an ion, I have to designate the number the elemental symbol. I have to designate the charge on that ion, and I have to say that it's aqueous. So if I'm looking at aluminum chloride, I'm going to say I have 4Al3 plus aqueous plus 12Cl minus aqueous plus, okay, now I'm looking at my second compound. I have 3 leads. Because the NO3 is a -1 charge, and there are 4 of them, I know that my lead has a +4 charge. So I have plus 3 Pb, 4 plus aqueous, plus 3 times 4, I have 12 NO3s, 12 NO3 minus aqueous, yields 4Al3 plus 4 times 3, 12 NO3 minuses, aqueous, plus 3 PbCl4 solids. You always leave the solids together as the compound. So I've got my ionic equation here. All right. Let's see if, okay, Gabe,
Yes.
nickel NiBr2. How many nickel ions do we have?
1.
What's the charge on that nickel ion?
Plus 2.
+2. Each bromine's a -1. And there are 2 of them. So the nickel's a +2. So I have 1 Ni plus 2. I have to put the aqueous there. All right, Gabe, how many bromines do I have?
2.
It doesn't matter if there's a coefficient in front or if it's a subscript. I have to multiply the coefficient times the subscript to tell me how many ions of bromine I have. So I have 1 times 2, I have 2 of them. The symbol's Br. What's the charge, Gabe?
-1 or 1 minus.
-1. Okay. How many sodiums do I have, Gabe?
2.
2 NAs. What's the charge on sodium?
Would it be a +1?
+1. I have to put the aqueous there. Now, how many CO3s do I have?
1.
1. CO3. It has a 2- charge on it, and it's aqueous. All right. That yields. How many sodium ions do I have here?
2.
Okay. 2 Na plus aqueous
1.
plus how many bromines?
2.
2 Br minuses, aqueous, plus this stays together because it's a solid. Okay?
All right.
Guys, how many of you drive across the Howard Franklin Bridge or have driven across the Howard Franklin Bridge?
Yes, I have.
Me.
Yeah. How many of you have been stuck in traffic before the hump?
Too many
have.
times.
Yeah, too many times to count. Ladies and gentlemen, I fume. I fume because I am stuck in traffic. And there damn well better be an accident somewhere in front of me so I can get my bloodthirsty outlet. I need to see blood, guys. So as I'm driving past the accident and I am looking, did I cause the accident? Did I cause that accident?
No.
No, I may cause another one, but I didn't cause that accident. What am I doing as I'm driving past that accident to satisfy my bloodthirsty angst? What am I doing, guys?
Not paying attention to
Got
the
it.
road.
What am I doing at The accident though.
Looking?
I'm looking, I'm spectating. I didn't have anything to do with that reaction that happened to cause the accident. All I'm doing is looking. Okay? That isn't the reaction that's happening. The reaction happened before I got there. All I'm doing is looking at it, spectating. Another example. You are up in the 100th row of the top of Raymond James Stadium. Last year you were there and you watched as Mr. Winston threw the pass right into the belly of the linebacker. And the linebacker caught it and ran it back for a touchdown. And you scream your bloody head off at Mr. Winston because you looked at it, right? Did you have anything to do with that interception?
No.
You are just looking at it. You are just spectating. Now, we have sodium in this particular equation. We have sodium. Sodium's only job in this equation is to deliver the carbonate. Bromine's only job in this equation is to deliver the nickel. They don't really do anything else. They just spectate what is really happening. Since they're not really doing anything, we can cross them out. We cross out the bromines, we cross out the reactant bromines, we cross out the product bromines, cross out the reactant sodiums and the product sodiums. What is left is the actual reaction that is occurring. I have nickel, 1 nickel plus 2, reacting with 1 carbonate minus 2 to make 1 compound nickel carbonate. And that is the net ionic equation. What we do with our net ionic equation is we eliminate the spectator ions. Now, guys, when you're doing a test, it's going to be a little bit difficult because we're doing this online. But if you can figure out a way to write your whole ionic equation there and then eliminate what's in common, whatever is left will be your net ionic equation. What you're doing is you are just eliminating your spectator ions from an ionic equation. All right, I'm going to go to the slideshow because it looks better that way. Okay. This is my iron chloride plus lead nitrate. What ions are the same, left and right? Cassidy.
It looks like all of them.
All of them?
Yeah.
Look at the chlorine and the lead, right?
Yeah.
Does this look the same as this?
Oh, no, sorry. I thought you meant compared to like the top equation.
No. I'm talking about, well, even the top equation. This lead and chlorine has changed to something else.
Yeah.
But what hasn't changed, Cassidy?
The aluminum and the nitrate.
Aluminum and the nitrates. So they can all be eliminated. And what is really happening is I have 3 Pb4 pluses plus 12 Cl minuses yielding 3 PbCl4 solids. And guys, you need to include everything that identifies the ion. The number of them, the chemical symbol, the charge, and the fact that the ion is aqueous, or the fact that it is solid. All right, Jasmina.
So,
All right. I want you to separate this into an ionic equation. I've given you the equation. So NiBr2, what does that split up into?
I'm looking at the charges. Give me 1 second. Nickel +2 and bromine -1.
All right, what did you forget, Jasmina?
The aqueous.
Aqueous for the nickel +2. You also forgot something for the bromine.
Yeah, aqueous for both of them.
All right. How many are there?
There's 2 bromines.
Okay, you have to put the
Right,
number in there as well.
Okay, yeah.
All right, split up the sodium carbonate.
Two sodium +1, and then carbonate -2. Is it -2?
Minus
I don't
2.
remember. Okay, yeah. And both aqueous.
Okay, you have to put that all in there. Okay, Ian, you there, Ian?
Yes.
Okay. I'm going to see who's here. And if I haven't forgotten anybody. Layla, I've been forgetting you. I'll get to you next, Layla. Okay, Ian, you're going to do the products now.
Okay.
Break this down. How does that break into ion form?
2 Na aqueous plus 2 Br aqueous plus 1 Ni plus 1 C or 1 CO3 solid.
Okay, a couple things, Ian.
Yes.
All right. You didn't tell me the charge on each one of them.
Oh, my bad.
Okay, so it's 2 Na plus aqueous plus 2 Br minus aqueous. Now, the second thing you did, what does this symbolize?
Solids.
So, do you break this up?
No, you leave it together.
Okay, good. And Layla, you were trying to sneak away in there, weren't you? Staying real quiet so I wouldn't notice you. Okay. What Jasmina and Ian did was they created the whole ionic equation. Now, Layla, you got to tell me what's the same, left and right.
The 2Na plus, 2Br minus.
So what can I do with that?
You can cross them out.
I can cross them out. And whatever is left, the Ni plus 2 aqueous plus CO3 2 minus aqueous makes 1 NiCO3 solid. Okay? Are we good with that?
Yep.
Okay. Yeah, I think I have time to, I definitely have time to get through this. All right. Now, you have single replacement reactions. All right. What happens in a single replacement reaction is a more active neutral atom replaces a less active cation or anion. If I am dealing with halides, halides always appear neutrally as a symbol and a subscript 2 down there. They always appear as diatomic molecules. So if I see a halogen there, I know it's a neutral species. What also it has is I have one ionic compound. I recognize single replacement reactions because they have one ionic compound and a neutral thing here. That's how I recognize it. The neutral thing is either going to be a halogen or it's going to be a metal. All right, let's bring back the Flintstones again. Fred's with Wilma, okay? And Fred gets tired of the redhead and he looks over at the other side of the room. He sees his cute little brunette over there, Betty. So what happens is Fred kicks Wilma to the side and he goes after Betty. So we have the cation. We're going to deal with this one first. We have the cation Fred reacting with the normal metal. The normal metal kicks out Fred, and I'm sorry, my analogy just went to hell. Okay. Let's do it this way. Fred is D, sees Barney with Betty. He likes what he sees. So what Fred does was he pushes Barney out of the way and goes with Betty. And we now have a new partnership, Fred, Betty. Poor little Barney is sitting all by his lonesome. So what happens is the neutral species will display the corresponding ion. If we're dealing with a metal, and that metal is more active than the cation, the metal will displace the cation and it will become the cation, and it will be with the anion. The cation then will appear as a neutral entity. If I have a halogen, and the halogen is more active than the corresponding anion, which is going to be another halogen. If the halogen is more active than the anion, then it kicks the anion out, and it is now with the cation. And the original anion is now neutral, and it will appear as a B2. Is that, did I screw you up with my explanation?
No.
Remember this. The more active species will always end up being ionic. It will end up with a charge. So we have an activity series. You don't necessarily have to copy this down. All you need to know is that within the reactions PowerPoint, you have an activity series that is listed. And it's within the single replacement reactions. Now, if I mix lithium ion with magnesium, lithium is more active than magnesium. If I mix lithium metal with magnesium ion, lithium is more active than the magnesium, so there will be a reaction. The lithium will replace the magnesium. If I have zinc metal and I have calcium ion, zinc is less active than the calcium, so no reaction will take place. Similarly for the anions, if I have F2 gas and I bubble it through sodium chloride, F is more active than the chloride, so it will react and I will make NaF. On the other hand, if I have I2 that I dump as solid material into NaBr, Br is more active than the iodine, so Br is going to stay as the ion. Remember, rule number one, the more active element will always be in the ionic form. That's rule number one. Rule number two, if a reaction occurs, then the reverse reaction will not occur. If the reaction does not occur, then the reverse reaction will occur. And what I'm talking about by the reverse reaction is if you draw out the entire chemical equation. The reverse reaction would be like taking the products, putting the products together to see if you make the reactants. Equation-wise, the way it looks. If you have AB with D, and D is a metal, D will replace A, mixing with B, so we have a new ionic compound plus neutral A. If I am looking at this as an ionic equation, I have A plus aqueous plus B minus aqueous plus neutral D, yielding D plus aqueous plus B minus aqueous plus A. Notice in my ionic equation, my B minuses are the same. They cancel out. So the whole net reaction is I have A plus plus D yielding D plus plus A. Are we good, guys? Let's get some examples in here. If I add Na to copper chloride, copper 2 chloride, and I know that Na is more active than copper, then does a reaction occur?
Yes. Right.
Na is more active. It wants to be ionic. So Na goes from neutral Na to Na plus. I do have a reaction. So what I make is I make Na replaces the Cl. So the first thing I do, I want to get out of here for a second. The first thing I do is, I do want to be in here. Never mind. Sorry. If I do that reaction, I get CuCl2 plus 2 NAs, making 2 NaCls plus Cu. My ionic equation. And what am I forgetting here, guys?
The states.
The states. You have to put the states in. I was a bad boy. I didn't. So you need to put the states in. Cu2 plus aqueous plus 2Cl minus aqueous plus 2 Na solids yields 2 Na plus aqueous plus 2Cl minus aqueous plus Cu solid. Jasmina, what's the same?
Yeah.
Left and right here.
Everything.
Everything's the same?
Oh, well, no, the copper doesn't have the charge.
Okay.
So,
Copper doesn't have the charge. What about the sodium?
so
Did the sodium change?
I'm not sure because I'm not sure if they're supposed to be, well, I guess so. There's no charge there.
There's no charge on this one. There is here. So the sodium's changed and the copper's changed. What remains the same?
The chlorines.
So I eliminate them and I have a net ionic equation of Cu2 plus 2 NAs yielding 2 Na pluses plus Cu. Okay? But if I put Cu metal and put that into a solution of sodium chloride, I get no reaction because the sodium is more active than the copper. The sodium right now already is in ionic form. So it doesn't want to have another electron thrusted upon it. So it stays as Na plus, and the copper will stay as the metal. All right, Gabe.
All right.
Aluminum, okay, I need to go back. Is aluminum more active than calcium?
No, sorry, I was muted.
Calcium is more active than aluminum. Does a reaction occur?
Yes, it does.
You just said calcium is more active than aluminum. Didn't you?
Yeah.
So doesn't the more active species want to stay ionic if it can?
Yeah. Oh, okay. Yeah, you're right. So,
Thank
okay,
you.
no,
Thank you for
no,
saying I'm right.
no,
I
no
don't get that
reaction.
said enough to me. You know that?
Yeah, no
So,
reaction.
there's no reaction with this. And I need to check that. All right. Layla. You there, Layla?
Yes.
Okay, now, I'm sorry, let's go. Remember the two metals, magnesium and silver, okay?
Mhm.
All right, I've got my activity series here, Layla. Magnesium and silver. Which one is more active?
Magnesium.
So if I mix magnesium with silver nitrate, you said that magnesium is more active. Do I get a reaction?
Yes.
What are my products?
Magnesium, I think that's nitrate.
And
Silver.
silver. Now, here's a tricky thing, guys. All right, let's look at the next one. Okay, I've got iron and copper chloride. First of all, I recognize this as being a single replacement reaction because I've got a neutral species and I have an ionic compound. I'm going to go back. Iron and what was it? Anybody remember?
Copper.
Copper.
Copper. All right, I have iron and I have copper. Which one is more active?
Iron.
Okay, so do I get a reaction, Cassidy?
Yes.
You get a reaction. Now think about iron. Think about iron. Is it a type 1 metal or a type 2?
Type 2.
Do you know the charge iron's going to have?
No, because it has multiple charges.
So basically, I can't really give you this on a test question because you don't know whether the product's going to be FeCl2 or FeCl3. If
Okay.
you see that on a test, if for some reason I lose my mind and put something like that on a test, call me up immediately. Call me up immediately and tell me that there is a mistake, okay?
Okay.
Because I can't give you something like that because you can't predict the products. Fair enough, guys?
Yes.
That's why you need to keep my phone number handy when you are taking the test. All right? Ian.
Yeah.
All right. Remember silver and hydrogen.
Got it.
All right. You got silver and you got hydrogen. Which one is more active?
Hydrogen.
Okay, so when I put HCl with silver,
Yes.
do I get a reaction?
Yes.
You said hydrogen is more.
Oh wait, no.
All right. This one is no reaction. Now, I need to point out something else to you here. This is a special type of a single replacement reaction. When I add a metal into an acid, okay? Say if this was not silver, say this was sodium. Sodium is more active than hydrogen. Does a reaction occur, Gabe? If I change this, if I change this to, and show, if I change this to, instead of silver, if I change it to, oh, what do I want to say? Zinc. No, zinc's there. 1 second, I'll find something. Single replacement. Where's the single replacement? Where's that activity series at? There it is. Calcium.
Yes, you'd be able to like switch it, right?
All right. Calcium is more active than hydrogen, so is there
Yes.
reaction, Gabe?
Yes, there is.
Okay, so I get Ca, Cl2,
Right, Cl.
correct?
Yes, yes, you do.
What's the neutral species?
Hydrogen, H2.
H2. Remember, hydrogen's diatomic. You got to put the 2 in there, okay? Now, you're observing this. You're observing this reaction. You put calcium into HCl. Can somebody tell me what you should be observing? What are you going to see? What evidence of a reaction are you going to see?
Bubbling?
You're going to see bubbling, guys. You just created hydrogen. Hydrogen's a gas. HCl doesn't really bubble. So if you put calcium into HCl, you're generating hydrogen gas. You will see bubbling. Okay? It's about 11:15, guys. We've actually gotten further than I thought we would. So we're in good shape. Okay?
Woohoo.
Anybody, woohoo, thank you. Anybody have any questions for me? Anything about anything, quizzes, homework, anything?
Yeah, I have one question. Sorry.
No.
So for the quizzes, I noticed 2 quiz grades are dropped right now. Is that going to be like for the whole semester?
Yes.
Okay. And then my other question was, oh yeah, so we have another scavenger hunt for the question or student forum.
Did I tell you to do the scavenger hunt?
No.
I thought,
Well, actually, maybe you did last time, but I had to leave early because I had class at 11.
Yeah, it hasn't been mentioned because I've honestly been kind of confused on what's
Yeah,
going
me
on.
too.
all
With
right,
the
let's go.
forums.
Let's go.
And that was all I've really done.
Okay. I'm going to stop share, guys. And I'm going to share screen again. And I'm back to this. Okay. I think what I told you to do was use the response to the scavenger hunt as one of your three things. Okay.
We do 3 comments a week regardless if we attended the Zooms or not, right?
You have to do three a week, whether you attended the Zooms or not.
Okay.
All right. Well, let me do this. I want to make sure that you can see it. I'm going in as a student now. I'm going into the course content. And I'm going into the forum. And okay. All right. This is what I have done. All right. I'd like you to do the scavenger hunt answers, and it can count as one of your responses for this week. All right.
Okay.
If you answer this, the person that gets the most right out of the class will get 3 points, 2 for second place, 1 for third place. Understand, I've used the answers you guys gave to these questions. I've used them to make up new questions, and I'm using your answers from the first one to determine the answers to the second set of questions. For example, who was the most athletic? The question I asked here was, how many points did you score in high school? So you have to search through the first set of answers, through all those answers, and try and figure out who you think was the most athletic in high school. The most erudite, I used, what is the most scholarly book you've ever read? Now, understand these are subjective answers. I've come up with who I think is the most erudite based on this question. And so your answer may not exactly match mine. I've used what was the first movie you ever remember attending? And this is very, very off the wall, to who is the oldest. Basically, you look at the movies that they saw and you kind of try and figure out which was the earliest released movie. And from that, you choose who's the oldest. My answer to my first movie would have been The Music Man. I remember seeing The Music Man in a drive-in theater when I was probably about 5 or 6 years old. Okay.
So are we supposed to do the student or the scavenger hunt answers plus a student talk this week, or just the scavenger hunt answers?
It will count as how many, Gabe?
Oh, as one. Okay.
All right. So yes, you have to do this, and you have to, you don't have to do this. I'm not going to hold you to doing this. You can do 3 other responses if you want.
Okay.
It's just if you do it, I will count it as one of your responses. Okay.
All right. Perfect.
Does that, sorry, who asked the question? Jasmina?
It was Cassidy.
Cassie, I'm sorry, Cassie. Are you understanding what I'm doing here now?
Yeah, I do now. Thank you. I was just confused at first because I couldn't attend the first week's Zooms because of work and I was moving. So I just kind of went in and put all the answers, but I saw that people did it in segments. So I didn't know if there was some specific way
I don't
that
know
you
why
wanted
they
it.
did that. I don't know why they did that, because when I did, this is how, do you see this?
Yeah.
I specifically made the directions, put it in one response because it's easier for me to collate them.
Yeah,
Once.
that's what I thought. So I just put all of my answers in one. I was just
And
confused.
you got,
I assumed the other students had maybe attended the Zooms and were told separately,
no,
but I just decided to put it all in one.
that worked. That worked
Okay.
for me.
Yeah, that was the only question I really had just because I kind of forgot about that and I just wanted to make sure I was on the right page for it.
No problem. Gabe, did you say you had a question with the quizzes?
Oh, no, you answered it.
Okay. Anything else, guys?
Thank you so much.
Yes, thank you.
No. Did it help? Did the reactions lecture help you guys?
Yes.
Yeah,
What
for
can
sure.
What can I do better about it? If you
Honestly, sorry, you can go ahead.
go ahead, Cassidy.
I was gonna say, I just think I'm just kind of need to do practice examples just to like get it down pat, but that's just kind of it.
All right. I'll be honest with you. The homework that's assigned doesn't really go into it that well. So if you go into the modules for test 1, and I think this is in, I'm either going to see it in a second or not. Yes. Okay, extra homework for day 3. All right. And I need to download it. Are you still seeing the screen, by the way?
Yes.
Okay. This is the homework for that. I get a series of 10 reactions that you can practice doing the balancing. I get a predicted products. Basically, you got a compound that begins with H and the other compound ends in OH. What kind of reaction is this?
Acid base.
Acid base, exactly. I would count, if you answered double replacement or acid base, I would count them both as correct responses. Okay? You're going to need to see this is an acid base reaction. From that, you're going to recognize what the two products are. And the third one, you got to do the full ionic and net ionic. So this is one of the occasions in which doing the extra homework is going to help. And the other nice thing is, if you look here, right below it, you have the answer sheet. Thank you. Okay, so you have the answer sheet right behind it, all right?
Okay, perfect.
Good enough?
Yes, thank you.
No problem. Okay, guys, I will see you on Tuesday. You are going to do chem reactions in moles. Guys, I'll be honest with you. I'm probably going to get to start empirical formulas. And empirical formulas are going to be the hardest problems you deal with all semester. Okay? So the more time I can get on empirical formulas, the better. All right. Take care,
Thank
guys.
you.
I will see you on Tuesday.
Thank you.
Have a good weekend.
Have a
You
nice day.
too.
Thank
You too. Jessica, anything?
No, I'm good.
The reason I ask is I always look at my last screen because sometimes students want to wait until everybody else gets out and then they want to ask me a specific question. So that's why I always go to this screen and see if anybody's left.
Oh, no, thank you. I'm good.
All right. Take
Thank you.
care. I will see you on Tuesday.
Okay, you too. Bye.
Bye.